Our today's agenda is what is Ethernet protocol? What are all the fields exist in Ethernet packet header? How to craft this Ethernet header by using Python Skippy module and a quick demo. Without wasting time, let's move on to the session. So basically what is Ethernet? Ethernet is a traditional technology basically for connecting a wired network in a local area network. So as a data link layer protocol in TCP/IP stack, Ethernet describes how network devices can format and transmit the data so that other devices on the same local area or campus area network segment can recognize, receive, and process them. So, an Ethernet cable is a physical wire over which our actual data will be traveled. Any device accessing a geographically localized network using a cable, that is with a wired rather than wireless connection, likely uses Ethernet, whether it is a home, school or office network. If it is a wired, it is a Ethernet. From business to gamer, diverse end users depends on the benefits of this network connectivity, including reliability and security. Because over the when we compare with wireless, wired is always a fast, reliable, and secure because there is no fluctuations in that network. So this is the cable which actually referring when we are talking about a wired rather than a wireless. So this is the cable which we actually see in our homes or office networks, where this is the wire actually it look like, and this is where we actually insert, that is the NIC card. So either it is a monitor, desktop, a laptop, or it's a switch or router which is having this network connectivity for wired. It will have a NIC card. So that is where that is a NIC card or switchboard, that is where we actually insert this RJ45 connector. So this wire is nothing but an RJ45 connector which we insert into a NIC card, and through you by using this Ethernet protocol, the actual data will be transferred through this wire. So if you see this image here, this RJ45 connector actually have 8 pins, that is called 8 spots. So when you insert, right, the data will be delivered or transferred by using this 8 ports. Hope you understand this. What is that Ethernet? What is the benefits of Ethernet, right? Let's move on how the Ethernet packet header actually looks like. So if you see this header, there are total 7 fields, and the one of the greatest thing about Ethernet is all two we have different standards. They all use a common Ethernet frame, that is this. So this frame hasn't changed much since original Ethernet standard from the 70s. So this is how actually the frame look like from 70s. Much there is no much change in it. So let me explain you the different fields here. The first one is primable. So this primable, right, it's a 7-byte pattern of just ones and zeros. This is basically used for synchronization. And the second one, SFD, start frame delimiter. So this marks the end of primable and tells the receiver that the next field will be the actual Ethernet frame, starting with the destination field. And you know the destination and source, right? This is the destination MAC address of the receiver and destination MAC address of the sending frame. And this type tells us what is carried inside the Ethernet frame, whether it is a IPv4 packet, IPv6 packet, ARP packet, whatever it is, the type will tells us, okay, this is this kind of packet, this is IPv4 packet, this is ARP packet. And data, this is the field actually carries the data, while trying to transmit, for example, IPv4 packet or ARP packet. And FCS, the frame check sequence, actually helps the receiver to figure out if the frame is correct or is there any corruption in it. So if you see the color, right, the fields which are marked in green are what we call the Ethernet header. So till this five fields are actual Ethernet header, and this is the data and FCM will be added while sending the packet, which are not part of actual Ethernet header, which is part of all the packets. So let's concentrate on only these first five fields, and let's see how we can craft this Ethernet packet by using this SCAPI module. So this is all about the description. It's a theoretical description, which is actually not our focus main here, because we more likely uh, want to learn how we can craft this packet by using this Python program and SCAPI module. So let's create our first Ethernet packet by assigning some fields to it. Let's see how we can do this by using a SCAPI module. So before jumping into creating a packet and checking all these packets by using SCAPI, I assume that you have installed a Python 3 and a SCAPI module. So let me open my terminal command prompt where I already have a SCAPI module installed. Let me quickly open it. So if you have installed and set the path properly, from your terminal run a SCAPI command that actually will take you into SCAPI interactive shell. It will take a little bit time. Okay, so we entered into a SCAPI interactive shell. So from here, by using the commands which will see in just a quick second, so to create and send out actual the bare Ethernet frame. So if you see here, so this is how we actually will import all the functions from the SCAPI module. If you use a Python, Python interactive shell, but when you already enter using a SCAPI interactive shell, this command will not be required, because you're already into a SCAPI shell where SCAPI interactive shell already loaded with all required modules. So if you see here, look at this Ethernet header. This command will show you what are all the fields which we actually have seen in this slide, right? So it will show you all the fields from the Ethernet header, and it will show you the length of the Ethernet header, and this actually will use to send the packet. So without wasting time, let's create our first Ethernet header packet. Let's see how we can do that. So first let's see what are all the content that are available in Ethernet header by simply executing this command. So if you see this, these are the three main fields which actually have control. The first two fields, right, the Primable and SFD, which are not required and which we actually do not control with manually. So these are the three fields mainly which we actually can control by using this KP module. And if you see the length of the Ethernet header, and you can see here either it's a 14 bytes, total 14 bytes. You can see that here. So 6612, is it this one? So these are all the three fields which are provided by SCAPI, and the length of this header is 6 plus 6 plus to 14 bytes. So that is what it here written, the 14 bytes. And let's populate the fields, how we can crop this packet. So let me create an object for the Ethernet packet first. So I'm creating an object for Ethernet header and the PKT, and let's assign some values to it, like a destination MAC address. Let's say 0011, and let's assign source as well. I'm just changing this last two bytes, 66 and 2, and this is the source. Let's show this packet object. So if you see this, these are the fields which actually provided by SCP Ethernet header, and these are all the fields which actually we set. And we see, right, the type, if it is a IPv4 packet, IPv6 packet, or packet, we can assign the type as well. For this example, let's see, I wanted to assign this type as IPv4, and IPv4 header byte value is 0800. And if you describe the packet, here you can see this is the source and destination, and the type is IPv4. So this is a bare Ethernet header packet. And if you want to send this packet, let's see the summary here first. Before that, packet dot summary will give you, the summary function will give you the overview of the packet. So this is the source, so we are sending to the destination, and the packet type is IPv4. So as this demo, we have just now created this packet, and it is time to send the packet. So in order to send a packet, basically we have a function called sendp. If you remember from our SCP tutorial, there are 4 functions which actually will be used to send the packet, and this is another one. It's a sendp, which actually send the packet, Ethernet packet, directly onto the wire. It only sends the packet, and it will not return any output. So let's see how we can send this packet out of the wire. And before sending the packet, let me open a Wireshark where we actually can filter the packet, I mean capture the packet, and we can analyze the packet. So let me send my packet here by using this sendp and pkt send. So if you see this, send one packet, and go here, and if you see this IPv4 packet here, right, so this is the source which we set, sorry, destination, and this is the source which we have configured and type as IPv4. Forget about this is a malformed IPv4 packet, because we just have created Ethernet packet, but we haven't created IPv4 packet, because in this session we are only concentrating on how to create Ethernet packet. So we haven't created IPv4 packet, and we haven't populated IPv4 fields. That's the reason it is a malformed packet. So hope you understand, right? Let's see how actually we can send and receive the packet by using this SCP module. So there is a command, right, we can use to get the response back. So if it is response equal to srp of 1, so if you remember from our SCP tutorial, this srp actually will send response packet, return 1 in response. If you are not familiar with the srp function, just go back to our SCP tutorial and get some understanding what this function will do. And let's execute this command here. So here, if you see, it sent one packet and received one packet, sent one packet, received one packet, and got one answer. So the response is now stored into this response object. Let's open this response object and show that. So this is the response which I have received actually. which is similar to send packet, because we haven't sent the proper packet, so we will not get a much response from it. So this is the output which we have received. Understand, right? So this is how we can send the packet in Scapy module by using Scapy module. And if you want to analyze the packet, so we can simply use this hex dump, which actually display hexadecimal bytes of the data. So if you see this in Wireshark, right here, this is the output of hexa value which we have received the packet. So simply we can use this hex dump, this command, right? Hex dump command, and that response we can get the hex value of the get given response. So this is the same as the output which we have seen here in the Wireshark. So without having this, gives you a brief understanding on, without having this third party tool like Wireshark, we can simply analyze the packets by simply issuing a single lines of commands by using this Scapy module. I think that's all for this session. I hope you understand what is Ethernet header and how we can craft Ethernet packet by using Scapy module, and you understand the demo as well. Thank you so much.